Good day students. So in our last session we have seen about single pass assembler. Single pass assembler, it will execute the instruction in a single pass itself, single scanning itself. So while scanning a particular line, it will execute it. In case of forward reference, there are certain procedures to handle the forward reference problem. So we have already discussed it in our previous session, how the single pass assembler handles the forward reference problem, how it will execute the instructions immediately. Usually the single pass assembler is used in an environment where development and testing takes place. Now let us see about multi-pass assembler. So already we have seen single pass, two pass. Now today we are going to see about multi-pass assembler. That is those instructions that cannot be handled in two passes. If more than two passes are required, those instructions will come under multi-pass assembler. Now let us see an example for multi-pass assembler. Alpha, EQ, beta, beta, EQ, delta, delta, RESW1. See now, the first scan, I am reading this instruction, alpha, EQ, beta. We are having two symbols, alpha and beta. So what is the value of alpha? Alpha is equal to beta. Do we know the value of beta? No, we don't know the value of beta. So we don't know the value of alpha also. Now I am reading the second line, beta, EQ, delta. So now one more symbol has been known. So what is the value of beta? So the value of beta is dependable upon delta. Do we know the value of delta in the first pass? No, we don't know the value of delta. So we don't know the value of beta also. Then I am reading the third line, delta, RESW1. So the delta is already encountered. So what is the value of delta? The value of delta is the location counter value. So let me assume that location counter value is some 3. So the value of delta is equal to 3, 0, 0, 0, 3. Okay. Now one pass is over. The second pass, this is the second pass. Again I am reading alpha, EQ, beta. Alpha and beta already encountered. So the value of alpha depends upon beta. We don't know beta, so we don't know alpha. Then I am reading the second line another time, beta, EQ, delta. So the value of beta depends upon delta. So delta, the value of delta is known. So what is the value of beta? Beta is equal to delta. So the value of beta is 0, 0, 0, 3. Okay. This line is already encountered and resolved. So no need to go for, no need to read the line once again. So two pass over. Now I am reading the first line for the third time, alpha, EQ, beta. Now the value of beta is known. So what is the value of beta? 0, 0, 0, 3. So alpha is equal to beta. So what is the value of alpha? Alpha is also 0, 0, 0, 3. Then this line I already encountered, I already resolved also. So no need to read once again. So for handling this particular instruction, we need how many passes? 3 passes. So these kind of instructions, these kind of forward references problem, 2 passes are not enough. So we go for multiple passes. So multi-pass assembler is an assembler which make as many as passes are needed to process the definition of symbols. So only the portions of the program that involve forward references in symbol definition are saved in symbol table and are involved in multiple passes until the forward reference problem is refined. Only those portions will be undergone multiple passes until all the labels, all the symbols in the program get resolved. So undefined symbols are usually stored in a symbol table. Now let us take a typical program for multi-pass assembler and let us see how the symbol table is created while encountering each and every passes. Okay. So first I am reading, this is our program, half is it EQ maxln by 2, maxln EQ buffer minus buffer, P or EVBT EQ buffer minus 1, buffer reserve byte 4096 buff and EQ star. Now I am reading the first instruction, half is at EQ max len by 2. So half is it is equal to max len by 2. We are having two symbols, two undefined symbols. So max len is also not defined. So I have to create a symbol table. So this is the symbol table and you have to add the two undefined symbols. So half is it is also an undefined symbol I have written here, and max len is also an undefined symbol I have written here. So half len is equal to, half len depends upon what? Max len by 2. So you have to write here max len by 2. So half is it is depend upon how many symbols? Only one symbol, that you have to mention here as ampersand 1. So this indicates that one symbol in the defining expression is undefined. So in actual implementation, this might be stored at some other location and symbol table simply contains a pointer for it. Then max len. So the value of max len we don't know, so we have to mention it as a star. And the value of max len is needed for which symbol? Is needed for half is it. That you have to mention in linked list. So this linked list will contain the list of symbols whose values depend on max len. So the value of max len is needed by which symbols? That symbols will be mentioned here in linked list. Okay. So now over reading the next instruction, max len EQ buff and minus buffer. So already our linked list contains this information. Now max len is already defined in our linked list. So max len is equal to what? It is equal to buff and minus buffer. So max len is dependable upon how many new symbols? Two new symbols. So you have to represent it as ampersand 2. So buff and is also a new symbol. So you have to create a symbol table entry buff and buffer is also a new symbol. So you have to create a symbol table entry. So the value of buff and is also not known. Value of buffer is also not known. So the value of buff and is needed for what? Is needed for max len. So you have to write that in linked list. And also the value of buffer is also needed by max len. So you have to write it in linked list. Okay. Now I'm scanning the next line of the instruction. PREVBT EQ buffer minus 1. So PREVBT. So this is also a new symbol. So you have to make a symbol table entry. PREVBT. So PREVBT is equal to what? Is equal to buffer minus 1. So PREVBT is dependable upon how many new symbols? Only one new symbol. So you have to represent it in here, ampersand 1. So buffer is also a new symbol. You have to first check whether buffer is already defined in the symbol table. Yes, buffer is already defined. So the value of buffer is not known. So the value of buffer is needed now for PREVBT label also. So you have to mention that label in linked list. So when the value of buffer is known, it has to given to two symbols, max len as well as PREVBT. Okay. Now I am reading the next instruction, buffer RESW 4096. So consider, let us assume that buffer, the location counter value for buffer is 1034. Okay. Now the value of, what is the value of buffer? Buffer value is equal to the location counter value, that is 1034. So now we have obtained the value for buffer. So you have to go and check in the symbol table where buffer is present. So buffer is present here. So already we have marked null for buffer because we don't know the value. Now we have known the value for buffer. So what is the value? 1034. So you have to insert here 1034. Okay. So the value of buffer is needed for how many symbols? Two symbols, max len and PREVBT. So just go and insert the value for buffer in max len. Okay. So max len is equal to buff and minus buffer. So the value of buffer is 1034. And also you have go and insert the value of buffer in PREVBT. PREVBT is equal to buffer minus 1. So buffer value is 1034. 1034 minus 1 is equal to 1033. So PREVBT is resolved. Okay. Now we are reading the next instruction, buffered EQ star. Let us assume that the location counter value for buffered is 2034. So the value of buffered is 2034. You have to go and add the value 2034 in buffered. So buffered is present here. Initially we don't know the value. Now we know the value. What is the value? 2034. So the value of buffered is needed for with how many symbols? Maxlen. So you go and insert 2034 in maxlen. So maxlen is equal to buffered minus buffer. So what is the value of buffered? 2034. Buffer is already known. So 2034 minus 1034 is equal to 1000. Okay. So we have resolved maxlen. So the value of maxlen is needed by which symbol? Half Z. So you go and insert the value of maxlen in half Z. Half Z is equal to maxlen by 2, that is 1000 by 2 equal to 500. So this also resolved. So finally all the symbols are resolved. So this is how a multipose assembler handle the forward reference problem. So each undefined symbols is marked in the symbol table and the symbol table entries are resolved as many as passes until all the definitions are encountered. Thank you.